Okay, in this lesson we're going to look at some applications of implicit differentiation, and the first one we're going to look at is writing an equation of a tangent line at a certain point. And since this is going to involve taking the derivative of y and x with respect to x, we're going to end up with an equation of a line. And here in this problem they've already given us these two values here. X is 0 and y is 1. So ultimately what we're going to do is we're going to write this equation. We already know the y value, and it's going to be equal to, and we're going to plug in the derivative right here, dy over dx. But we're going to have to put that value in for 0 and 1. So we're going to have to plug in an x and a y, where normally we were just doing the x value. And since we already know the x value is 0, our equation is going to look like this. So let's go ahead and take a look at the derivative, and then we'll plug in our given values of 0 and 1. So remember, every time we take the derivative of y, we're going to have to write our dy dx. So let's jump right into it. The derivative of 3y squared, or y cubed, is 3y squared. And since we took the derivative, we're going to put a y prime or dy dx. The derivative of 1 is 0. So we'll put minus 0 there. And then we're going to have a product rule here, where this first x is going to be our f, and our g value is going to be our y. And so it's going to look like this. The derivative of 4x is 4. With respect to x, you don't have to put the dx over dx. Then we're going to add, don't touch f, and the derivative of y is 1. So we're going to put a y prime because we took the derivative of y. And then we have minus a 3x squared. Okay, so then we're going to just keep on going, and we're going to collect our y primes on one side of the equation. And looking at it, it looks like only we have a 4xy on the right side, and we have our 3y squared y prime on the left side already. So let's move that plus 4xy prime on the over to the left. So moving right along, we have 3y squared y prime minus 4x y prime. All of that equals our 4y minus 3x squared. So now that we've done that, all we have to do is factor out our y prime. And factoring that out, we get the following. We're just going to pull that out. We're going to y prime is equal to, or excuse me, back that up. All that's times 3y squared minus 4x. And the right side we haven't changed yet, so it's just 4y minus 3x squared. Now that we've separated our y prime, we're just going to simply divide by this quantity right here. So doing that, we'd end up with y prime. In the numerator we have 4y minus 3x squared, and the denominator is going to be what we just divided, 3y squared minus 4x. Okay, so now that we've done that, we're just going to simply evaluate this thing at x equals 0 and y equals 1. So the notation that we do in that is just put a little set of ordered pairs down here in the bottom, and that's just telling us what we're going to do next. So let's see if we can do that. So we have 4 times 1 minus 3 times 0 squared. Of course, this is 0. All over 3 times 1 squared minus 4 times 0. So it looks like our slope is just simply 4/3. So we just found y prime at 0, 1. So all we have to do is plug that back into our original equation that we started up at the top, and we should be done. So we'll do it right here in purple. We have y minus 1 equals to 4/3 times x. And that's it. Okay, we'll take a look at another video where we have to maybe take the second derivative.